Number 4. I got a lot of questions on this particular problem in class. Okay? Let's try to unpack it here. The lattice energy of compound A is than that of compound B. What can be concluded from this fact? Here, we're being asked to use our understanding of lattice energy, but simply knowing the definition of energy is not going to get us the point here. Also, if you're only reading 2 or 3 words in this question, you will not get the right answer. If you looked at the word magnitude and that's the only word you read in this question, and therefore you think it has something to do with the size of the crystals, you will not get this question right, and you won't be even close. Number 4 reads, the lattice energy of compound A is greater in magnitude. What is lattice energy? It's the amount of energy released during the formation of a crystal lattice. Why would there be energy released in the formation of a crystal lattice? Well, in number 3, last video, we identified that the only reason that a compound will form through bonds is that the bonded form is a lower energy configuration than the neutral lone atoms. And so both of these crystals, compound A and compound B, have lowered their potential energy when they came into this form, right? Compound A and compound B. To say that the lattice energy of compound A is greater in magnitude is to say that the amount of energy released when compound A formed is greater than the amount of energy released by compound B when it formed. And if you release more energy, you have less potential energy left over after that event. You have less potential energy. And what do we know about nature? Nature favors low energy configurations. So if you lose more energy than another compound when you form, like here A released more energy than compound B during their formations, that means that more than likely compound A is going to be at a lower potential energy configuration than B. To be at a lower potential energy configuration is the same thing as being more stable. And when you are more stable, it is more difficult to break the bonds that hold that compound together. So here the correct answer is B. It would be more difficult to break the bonds in compound A than those in compound B.